Hello everyone. Today we'll be discussing the quick solutions of All India Caste Test Series Test 4A Paper 2, which was held on 24th November 2019. So let us start with question number 41, which is an integer type question. So figure shows the roadmap of city. There are two police checkpoints at C and D who penalize for any traffic violation. A boy is going to B from A on a bike without helmet following the shortest route. The probability that boy is not penalized is P by Q. Then we have to find 2P minus Q. Right? Now, let us talk about total number of cases first. It is equivalent to arrangement of 5 alike and 6 alike objects, because we have here 5 and here also we have 6 steps. So it is like arranging 5 alike objects and 6 alike objects. So total number of elements in sample space, it is equal to 11 factorial divided by 5 factorial into 6 factorial, because these 5 are alike and these 6 are also alike. Now let us firstly find routes which pass through D. That will be equal to, so here firstly we have 3 steps here and 2 steps here. So that is 5 factorial divided by 3 factorial into 2 factorial. Now next we have to go from D to B. So here horizontally we have 2 steps and vertically we have 4 steps. So that is 6 factorial divided by 2 factorial into 4 factorial. Right? Now similarly, let's find routes that pass through C. So that is equal to 1 horizontal path and 4 vertical paths, that is 5 factorial divided by 4 factorial into 1 factorial into, now here we have 4 horizontal and 2 vertical steps, that is 6 factorial upon 4 factorial into 2 factorial. So this is equal to 5 into 6 upon 2, that is 25 into 3, that is 75, and value of this will be equal to 10 into 5 into 6 divided by 2, that is 150. So our required probability of event E will be equal to 1 minus if the person passes through C or D. So it will be 1 minus 150 plus 75 divided by number of elements in sample space. So this is equal to 11 into 10 into 9 into 8 into 7 divided by 5 factorial, that is 120. So this goes by 3, 42. So this is equal to 6 into 7, that is 42 into 11, which is equal to 462. So required probability will be here divided by 462, that is equal to 1 minus 225 divided by 462, which is equal to 79 upon 154. So value of 2 into P, that is 79 into 2, 158 minus 154 is equal to 4. So 4 is our required answer. Next is question number 42, which says that 2 Indian and 3 American couples are to be seated around a circular table. The probability that every American man is sitting adjacent to his wife, if it is given that every Indian man is already sitting adjacent to his wife, is P. So we have to find the value of 105P. So question from Bayes' theorem, we have to find the probability that every American man is sitting with his wife, if it is already given that Indian man is sitting with his wife. So we have here 3 American couples and 2 Indian couples. So this is equal to, we already know the formula, that probability of A divided by B is equal to probability of A intersection B divided by probability of B. So let's apply over here. It is equal to probability when American couple is sitting together and Indian couple is also sitting together divided by probability that Indian couple is sitting together. Now American couple and Indian couple both are sitting together. So we have, let us say M1W1, this is one couple, M2W2, this is another couple, M3 W3 another couple, M4 W4 fourth couple, and the last couple is M5 W5. This is the last couple. So we have to arrange them in a circular table. So 5 things can be arranged on a circular table with 4 factorial ways. Also, these two can arrange among themselves. These two can also arrange among themselves. Similar for all 5. So 2 factorial raised to the power 5. This is our required number of cases. Divide by. Now here it is given that Indian couple is sitting together. Let us say these two are together. Let us say this is one entity and this is also one. So now we have in total 1, 2, 3, 4, 5, 6, 7, 8. 8 things that we have to arrange in a circular table. So that can be done in 7 factorial ways. Also, these two can be arranged among themselves. So 2 factorial whole square. So this is equal to 8 divided by 7 into 6 into 5. So this is equal to 4 divided by 21 into 5. That is 105. So value of 105p is equal to 4. So 4 is our required answer. Now next is question number 43, which says that a die is loaded such that even faces are twice likely to appear than odd faces. That is, probability of occurrence of even faces 2 by 3 and probability of occurrence of odd faces 1 by 3. Right? Now, when the die is rolled n times, the probability of getting an even number at least 2 times is 8 by 9. Then we have to find n. So 8 by 9 is given to be equal to probability of getting an even number at least 2 times. So we can write it equal to 1 minus probability of getting even number 0 time. Also subtract the probability of getting even number 1 time. So right hand side is giving us probability of getting an even number at least 2 times. Right? So 1 minus 8 by 9, that is 1 by 9, is equal to probability of getting even number 0 time. So it is rolled for n times. So it is nc0 into 2 by 3 raised to the power 0 into 1 by 3 raised to the power n plus probability of getting an even number 1 time, that will be nc1 into 2 by 3 raised to the power 1 into 1 by 3 raised to the power n minus 1. Right? So we get from here 1 by 9 is equal to 1 by 3 raised to the power n plus 2n divided by 3 raised to the power n, that is 2n plus 1 is equal to 3 raised to the power n minus 2. So this is our required condition. It is given that n is greater than 2. So by hit and trial we can say that if I put n equal to 4, then on the right hand side we get 9 and on the left hand side also we get 9. So n equal to 4 is our required answer. Question number 54 says that if the number of pairs of parallel planes containing 4 fixed known coplanar points is n, then we have to find n by 2. Right. So here we have to find the number of pairs of parallel planes which contain 4 fixed known coplanar points. So let us firstly take 3 points here on any one plane and we will take the 4th point on the other plane. So this can be done in 4C3 ways, because in 4C3 ways I have selected any 3 points from all the 4 and then pass them from any one plane, and then the 4th point that is left can be passed through another plane. There is only one possibility for that. So total number of planes is 4 from here. Also another possibility is that if I take 2 points here and another 2 points on the second plane, so that can be done in 4C2 ways, that is equal to 6. So these two are the only possibilities. So total number of such planes will be 10. So value of n is 10. So value of n by 2 is 5. Next is question number 45, which says that a die is loaded such that the probability of occurrence of face I is proportional to I square for I equal to 1, 2, 3, 4, 5, 6. When the die is rolled twice, the sum of two numbers obtained is 10. then the probability that 6 appeared in the first row is P by Q. Again, a question of Bayes theorem. We know the probability of A when B have already occurred is equal to probability of A intersection B divided by probability of B. Now here what we have to find the probability that 6 appeared on first throw when it has been given to us that sum of two numbers obtained is 10. So this is equal to probability of this intersection this, that is 6 appeared on first throw. Now if sum is 10, then 4 must have occurred on the second throw, right? Divide by probability that sum of 10 has occurred. Now let us firstly find the required probability. Now probability of occurrence of 1 is proportional to 1 square. Probability of 2 is proportional to 2. It is proportional to 4. Similarly for 3 it is proportional to 9. 4 is proportional to 16. 5 is proportional to 25. 6 is proportional to 36. So this is probability. Sum of these values should be equal to 1. So we have 430 plus 25 plus 36 lambda is equal to 1, that is 55 plus 36 lambda is equal to 1, that is lambda is equal to 1 upon 91, right? So probability of occurrence of 6 is 36 by 91. Probability of occurrence is 4 is 16 by 91 and probability of occurrence of 5 is 25 by 91. So let us now solve the question. Probability of occurrence of 6 on first throw is 36 by 91. Probability of occurrence of 4 on second throw is 16 by 91. Denominator, we have to get sum as 10. How can we obtain sum as 10? If we obtain numbers on the dice as this. So in the denominator we have 36 by 91 into 16 by 91 2 times plus probability of occurrence of 5, that is 25 by 91 into 25 by 91. So solving this we will get it equal to 576 divided by 1777. So value of root of q minus 3p will be equal to 49. So required answer is 7. Next is question number 46, which says that if a1 vector, a2 vector, a3 and so on up to a10 vector are unit vectors such that summation of I going from 1 to 10, ai vector is equal to 4i cap minus j cap plus 3k cap, then the value of summation ai into aj vector where I is greater than equal to 1 is less than j is less than equal to 10. So it is given over here that a1 vector plus a2 vector plus a3 vector and so on up to a10 vector is equal to 4i cap minus j cap plus 3k cap. And what we have to find, if we put I equal to 1, then j can be equal to 2, 3, 4, 5 and so on. And if we put I equal to 2, then j can be equal to 3, 4, 5 and so on. So we have to find the sum of values like this. Now here if I take mod on both sides and take square, then what we will get? We will get mod a1 square plus mod a2 vector square and so on up to a10 vector square plus 2 times a1 a2 plus a1 a3 and so on up to a1 a10. Similarly plus a2 a3 plus a2 a4 and so on, right? What we have to find over here, let us say this is equal to p. So this is equal to modulus of this square, that is equal to 16 plus 1 plus 9, that is equal to 26. So also we are given that all these are unit vectors. So mod a1 square is 1, mod a2 square is also 1, so on. So we have 10 plus 2p equal to 26. So 2p is equal to 16. So p is equal to 8. So our required answer is 8. Next is question number 47, which says that if A, B, C are non-zero vectors such that B and C are non-collinear and A vector cross B vector cross C vector plus 2 times A dot B vector is equal to 2x plus sine pi y B vector plus x minus x square C vector. Also it's given that C dot C into A is equal to 3C vector, where x and y are scalars, so we have to find the greatest value of 1 upon xy, right? So it is given over here that C dot C into A vector is equal to 3 into C vector. So let us take dot product by C on both sides. So here it can be seen that these two can be cancelled because C is a non-zero vector. So we can say from here that A dot C is definitely equal to 3. Now let's expand this equation that is given to us. So we can write over here A into C B vector minus AB into C vector plus 2AB into B vector is equal to 2x plus sine pi y into B vector plus x minus x square into C vector. Now it can be seen that as B and C are non-collinear vectors, so coefficient of B vector on both sides should be equal. That is A dot C is 3. 3 plus 2 times A dot B vector is equal to 2x plus sine pi y. Also coefficient of C vector, that is minus of A dot B is equal to x minus x square. So A dot B value can be put from here to get the equation in x and y. So we get 3 plus 2 times x square minus x minus 2x minus sine pi y is equal to 0. That is 2x square minus 4x plus 2 plus 1 minus sine pi y is equal to 0. That is 2 times x minus 1 whole square plus 1 minus sine pi y is equal to 0. Now as both of these brackets are greater than equal to 0, so both should be equal to 0, which means that value of x is equal to 1 and value of sine pi y is equal to 1. So it gives us pi y equal to 2n pi plus pi by 2. So value of y is 2n plus 1 by 2. Now we have to talk about here value of xy. So xy, x is equal to 1 and y is 2n plus half. So value of 1 upon xy is equal to 2 divided by 4n plus 1. Now we have to talk about the greatest value of this. Now its greatest value will be obtained when the denominator is minimum, and that will be minimum when n is definitely equal to 0. So value is equal to 2. So 2 is our required answer. Next is question number 48, which says that consider an equilateral triangle PQR. Let A and B are 2 points on PQ and PR respectively, such that PQ vector is equal to 3 times PA vector and PR vector is equal to lambda times PB vector. If AR vector and BQ vector are orthogonal vectors, then we have to find lambda. Let us say this is our equilateral triangle PQR and A and B are points on it such that the conditions are given to us. So let us say P is 0 vector, this is Q vector and this is R vector. So A vector will definitely be Q vector by 3 and B will be R vector divided by lambda, right, according to the given condition. So it has been given that AR vector dot BQ vector is equal to 0 because they are perpendicular. So AR vector can be written as R vector minus Q vector by 3 into BQ vector will be Q vector minus R vector by lambda, right? So this is equal to 0, which means that R vector into Q vector minus, let us take the side of an equilateral triangle as A. So we can say A is equal to mod of Q vector is equal to mod of R vector. So this is minus of mod of R vector whole square, that is A square by lambda minus again A square by 3 plus Q vector dot R vector divided by 3 lambda is equal to 0. Now we need here Q vector dot R vector. Now we know that this is an equilateral triangle and this is 60 degrees. So let us take dot product of PQ vector into PR vector. So Q vector dot R vector is equal to modulus of Q vector into R vector, that is A square, into cos 60 degrees, that is 1 by 2. So we have from here Q dot R vector equal to A square by 2. So let's put it here. So we get A square by 2 plus A square by 6 lambda minus A square by lambda minus A square by 3 is equal to 0. So A square can be cancelled. So we have 1 by 6 plus 1 by 6 lambda minus 1 by lambda is equal to 0. So multiplying by lambda, so we get lambda by 6 plus 1 by 6 minus 1 is equal to 0. So lambda plus 1 minus 6 is equal to 0. So lambda is equal to 5. So 5 is our required answer.